He changed everything we thought we knew about time, space, and gravity. He gave us E equals mc squared, black holes, and a universe that curves and dances to the rhythm of relativity. But what if we told you Einstein was wrong several times? And not just about small details. Some of his most passionate beliefs turned out to be scientific dead ends. Welcome to the Curious Order, where today we explore the mistakes of Albert Einstein and why even his failures helped shape the future of science. Imagine for a moment a person stumbling through a pitch-black room, arms out in front, hoping not to crash into anything. Now, picture another person walking the same room, but with a flashlight illuminating every obstacle and deliberately choosing which ones to bump into, just to see what happens. That's the difference between most of us and Einstein. He was not a passive seeker of truth. He collided with it deliberately, fearlessly, and sometimes spectacularly. Here's the secret. Genius is not about never being wrong. It's about being wrong at a higher level. It's about asking bigger questions, taking larger risks, and daring to contradict the mainstream. Einstein did exactly that. Ironically, some of his most deeply held convictions were exactly where he got it wrong. But that's not a weakness. It's what made him extraordinary. The image of Einstein as the infallible sage, the ultimate authority on all things scientific, often hides a more human truth. He resisted some of the very ideas that now dominate modern physics. But his objections were never foolish. They were deeply philosophical, and they forced science to prove itself, to become stronger, and to answer the biggest questions with rigor. Take quantum mechanics, for example. Einstein helped give birth to the field through his work on the photoelectric effect, a discovery that won him the Nobel Prize. Yet, as quantum mechanics evolved, Einstein grew increasingly uncomfortable with its core premise, that nature, at its most fundamental level, is governed by probability. He looked at the randomness at the heart of quantum theory and famously declared, "God does not play dice with the universe." He couldn't accept that nature would leave anything up to chance. The clash didn't stop there. Quantum entanglement, the idea that two particles can be linked so that the state of one instantly influences the other, even across vast distances, sounded like nonsense to Einstein. He called it spooky action at a distance, and believed it revealed a fatal flaw in quantum theory. To him, this was not just counterintuitive, it was unacceptable. Einstein didn't merely object. He challenged the idea mathematically and philosophically. Along with Boris Podolsky and Nathan Rosen, he devised a famous thought experiment, now known as the EPR paradox, to show that quantum mechanics must be missing something. He hoped this would prove that there were hidden variables, a deeper order beneath the apparent chaos and unpredictability of the quantum world. For decades, the debate remained unresolved, a tug-of-war between Einstein's search for order and the strange predictions of quantum mechanics. Then, in the 1960s, physicist John Bell came up with a way to test Einstein's doubts experimentally. The results? Nature sided with quantum mechanics. Bell's theorem showed that local hidden variables, Einstein's preferred explanation, could not account for the observed behavior of quantum systems. Quantum mechanics, with all its weirdness, passed the test. Einstein's instincts were brilliant, his arguments profound, but the universe didn't agree with his desire for a deterministic world. Einstein's quest for a deeper order didn't end there. For the last 30 years of his life, he chased what he called a unified field theory, a single, elegant framework that would describe all the forces of nature. But, crucially, Einstein refused to include quantum mechanics in his theory. By excluding the very field he helped create, his search was doomed from the start. The world of physics was changing rapidly. New discoveries were revealing the strong and weak nuclear forces, fundamental interactions that Einstein never fully accepted or incorporated into his work. As particle physics moved forward, Einstein's vision of unification drifted further from reality, locked in a mathematical beauty that could not explain the messier truths emerging from the quantum world. But perhaps Einstein's most famous scientific misstep was the cosmological constant. Applying his general theory of relativity to the universe as a whole, Einstein discovered that his equations predicted either expansion or contraction. But at the time, everyone thought the universe was static. To reconcile his mathematics with the prevailing belief, Einstein introduced a fudge factor into his equations, the cosmological constant denoted by the Greek letter lambda. It wasn't a discovery, it was an adjustment made to force nature to fit human expectations. Then, in 1929, Edwin Hubble revealed that the universe is expanding. Einstein reportedly called the cosmological constant the greatest blunder of my life. Yet, in a twist worthy of science fiction, modern cosmology has resurrected the cosmological constant to explain dark energy, the mysterious force driving the universe's accelerating expansion. Maybe, just maybe, Einstein's blunder was more prescient than he realized. Even black holes, a spectacular prediction of general relativity, were a point of resistance for Einstein. He couldn't accept the idea that nature would allow for singularities, points where gravity becomes infinite and the known laws of physics break down. But black holes are now not only accepted, they're observed, mapped, and even photographed. Einstein's own equations foretold them, even if he doubted their physical reality. Gravitational waves provide another example. Einstein first predicted their existence in 1916, ripples in space-time caused by massive accelerating objects. But later, he doubted whether they could exist physically or be detected. It took a century, but in 2016, the LIGO experiment confirmed their existence, capturing the echoes of colliding black holes. Once again, Einstein's theory was right, even if he had stopped believing in his own prediction. So why did Einstein resist so many of these revolutionary ideas? The answer lies in his deep love for order, symmetry, and causality. Einstein preferred clear, deterministic laws over the uncertainty and randomness of the quantum world. This philosophical commitment blinded him to the possibilities that quantum mechanics offered, a realm where reality is shaped by probabilities, where observation changes outcomes, where the universe is fundamentally unpredictable. The double-slit experiment, for example, shows that particles like electrons behave like both waves and particles, and that the act of measurement itself affects the outcome. The idea that reality depends on measurement was something Einstein struggled to accept, even as the experimental evidence piled up. As physics marched forward into the age of particle accelerators and quantum field theory, Einstein remained focused on the beauty of geometric elegance. While others dove into the messy, chaotic world of subatomic particles, Einstein searched for mathematical perfection, and in doing so became increasingly isolated from the cutting edge of science. Einstein's theories relied on beauty and simplicity, but nature isn't always elegant. The real world, especially at the quantum level, is noisy, probabilistic, and weird. The man who changed everything couldn't bring himself to embrace that weirdness. And yet, there's a profound irony here. Einstein's skepticism, his relentless questioning, made quantum theory stronger. By challenging the mainstream, he forced scientists to develop better proofs, design more rigorous experiments, and think more deeply. His resistance was not a dead end, it was a detour that made the path forward clearer. Einstein's mistakes weren't failures. They were stepping stones, productive detours, even poetic in their own way. By daring to question, by refusing to settle, Einstein ensured that science didn't become complacent. His errors were not a flaw, but a feature of genius. Despite his scientific missteps, Einstein's place in history is secure. No one else so thoroughly rewrote the rules of the universe, and no one else made being wrong look so visionary. His legacy isn't just in the equations that bear his name, It's in the lesson that even the greatest minds are fallible. Being wrong is not a flaw of genius. It is an essential part of it. And the questions Einstein left behind still haunt modern science. What would he say about quantum computing, about the many worlds interpretation, about the mysteries he never solved? Perhaps in future explorations we'll pursue the puzzles he left behind and discover that science is still chasing the ghost of Einstein. Thanks for joining us on this fascinating journey through the beautiful mistakes of Albert Einstein. If you believe that curiosity is stronger than certainty, subscribe to the Curious Order. Every week we bring you stories that prove knowledge is not about having all the answers, but about asking the right questions. Welcome to the pursuit of truth. Your mind deserves this adventure.